Assalamualaikum warahmatullahi ta'ala wabarakatuh. In this part 2 video, we are going to continue discuss about chapter 7, managing project. Okay. We recap a bit what we should learn in this chapter. Okay. Basically, in this chapter 7, okay, you will learn about the IT project management issues and why IT project always fail, and also how to have a good project management by discuss about how IT managers manage the IT project. Okay, so these are the topic that we are going cover in this video. Okay, three antidotes: the art of lean project management and non-IT managers, where and how. Okay. Okay, why non-IT managers matter? Okay, it is because good IT project management increasingly indistinguishable from good business management. Okay, meaning that both cannot be compared. And invariably has an IT element, okay, meaning that any strategic move, business model tweak, or process improvement, usually they will involve IT elements, which non-IT managers must get them right. Okay, so IT project managers skill at managing technical skill, right? Meaning that IT managers can prevent IT projects from execution failure. For example, being over budget, late, or lacking quality. Okay, but only non-IT manager can prevent their business failure. Okay, meaning that under delivering the intended business benefits, okay, whether the IT delivered benefit the business or not, or IT project managers are themselves ill-equipped to tackle this, okay, which means that they cannot handle it. So non-IT managers' contributions in IT decision will make the IT development faster and cheaper with acceptable quality. Okay. Okay, usually IT projects fail to deliver business value because they lack with a clarity purpose, okay, unnecessary complex, and do not explicitly choose trade-off. So three times preventable mistakes which made IT projects fail to deliver business value are: the first one, ambiguity purpose, wrong system, meaning that it's failed because lack a clarity purpose, which result building the wrong system. Okay. The second one, unnecessary complexity, uh, meaning that made simple things complex. And the last one is non-IT managers silent on the triple constraint, okay, which mean cheap, fast, and good were not being explicit. Okay. Okay, we go detail one by one. The first reason why IT project fail to deliver is ambiguity of purpose, okay, which is the purpose is not clear. So this is due to poor biz IT communication equals to the wrong system. Okay, meaning that poor communication between business and IT that leads to building the wrong system. Okay. Okay, this first reason that leads to IT projects do not deliver their intended business benefits is not faulty execution, okay, but poor communication between business and IT. Okay, so this poor communication leads to building the wrong system. Okay, wrong system means if a project team accidentally built an IT system that nobody wants on it. Okay, so it does not matter if the project is on time and budget, okay, but it practically useless. Okay, the second one is unmet intended business benefits. Okay, it is not technical features. Okay, so the purpose need to be defined clearly. Okay, next is latent needs. Okay, means hidden needs. Okay, so for example, it's about a red brand story. Okay, this story tells about a company that made insect sprayers. Okay, which is this sprayer is technically very good. Okay, but the sprayer has been designed harmless to consumers, attractive color spray can, and low price. Okay, okay. In the first week of the product launch was great. Okay, very good response from customer. But after a week, what happened was most customer returned the spray can. Okay, and manager got puzzled and asked the customer what they really want. Okay. Apparently, what they want was they wanted to see the sprayed insect die immediately in front of them. But what happened was that the sprayed insect ran away and a few minutes later died. So the company then changed its formula by adding a paralyzing agent. Okay, and the formula able to make the sprayed insect from being able to move and die immediately. Okay, so actually this what exactly what the customers want. So the point of from this story is the company could not find the company could not find out what the customers later need by asking them what they want. And this is reality happen where IT project attempt to do that every day by attempting to get the requirement. Okay, so the thing is user or customer have to work collaboratively with the company to find out the later needs. All right, so this is very important because the latter needs defines the purpose of any project. Okay, okay. Next is IT project team cannot build what you cannot describe. Okay, and we call this unarticulated business goals. Unarticulated business goal lead to a lack of clarity about project requirements and forces IT project teams into a guessing game. And this leads to feature bloated and kitchen sink over engineering. Okay. Feature bloated system meaning that have many features that do not have many features that do a lot of things but do nothing well. Okay, kitchen sink mentality or of over engineer means uncontrolled growth in a scope of project. So again, we know that the antidote should come from the non-IT manager. Okay. So the last one is the cardinal sin is non-IT managers not articulating a business goal. Okay. Okay. Now the second reason of IT project fail to deliver is because unnecessary complexity. Okay, as a project grows larger, the risk of failure also will increase. Okay, the source of growing complexity is called ballooning scope, meaning that one system tries to do too much. Okay, the project complexity such as defects rise in proportion. Okay, integration problems compound and becomes comprehensible to any one person. Okay, so in order to remove unnecessary complexity and to make the project more manageable, non-IT managers must help IT team. Okay, okay, this figure illustrates a project's overall risk, which is the combination of its clarity of purpose um, and its complexity. Okay, okay, cell, for example, cell number 3 and number 4, which is in a shaded shell, are fatal combinations. Okay, cell 3 depicts a low complexity with low requirements clarity. Okay, like rudderless boats. Okay, may cause problems and cannot deliver business value. Okay, cell number 4 depicts high complexity with low requirements clarity. Okay, this is like a Titanic. Um, it is not a realistic business benefits and must be avoided. Okay, so viable projects fall into the other two unshaded, uh, unshaded cells. Okay, cell number 1 depict high complexity with high requirements clarity, uh, which is higher risk, and should lower the risk by prioritizing requirement. Okay. Cell number 2 depicts low complexity with high requirements clarity and lower risk. Okay. So the third reason IT project fail to deliver business value is failure to make trade-offs explicit because non-IT managers silent on the triple constraint. All right. So this figure illustrate the triple constraint model. Okay. The first one, basically an IT project can only have two of these triple constraints. Okay. You have to remember that if you try to achieve all three, then you are usually achieves nothing. Okay. Next is non-IT managers must make a decision to pick one to give up. Okay. So decision should be driven by the project business objectives. Okay. Uh, and if you have a constraint with time and money, then you have to restrict or reduce the project scope. Okay, non-IT managers must accept the project risk. Okay, these are two risks can be beyond non-IT managers' control. Number one is use of immature technology in a project. Okay, there is an enormous difference between such uncertainty and ambiguity. Okay, and project management only tackles ambiguity, but uncertainty requires real options thinking. Okay, the second one is underestimation of time and money. Okay, basically a well-executed project is judged by cost and schedule estimates. Okay, for example, low cost estimates can make a well-executed project looks like a financial disaster. So IT units um, tend to underestimate IT project costs and schedules for two reasons. Okay, number one is smaller commitments in terms of time and money are more likely to be approved. For example, often built in sufficient slack in schedule. Okay, over-promising leads to under-delivering. Okay, the second reason is estimation is more than art than science. Okay, meaning that a project interdependencies multiply, which mean the more interdependencies a project have, the more a multiplier effect can derail its schedule. Okay, for example, a less complexity project with a 70% chance of success is less risky than a more complex one with four interdependent projects that each have a 90% chance of success. Okay. Next, heuristic don't extrapolate across context and novel. Okay, even the most experienced IT expert cannot extrapolate reliable to unfamiliar market context and novel problems domains that an IT project might involve. Okay, t-shirt sizing rules. It is about better to be roughly right than precisely wrong. Okay, meaning that modern IT project management method can systematically refine initial estimates as the project proceeds, but don't want them to err by a huge margin. Okay, triangulate person hours effort needed. This is to triangulate initial project estimates using multiple estimation techniques to reliably arrive at close enough approximations of person hours of effort needed. Okay. We have three antidotes to business failure of IT projects, which are uh, discover a project's true business purpose, curbing scope creep, and accountability without micromanagement. So the first antidote is discovery of purpose. Okay, this antidote discover a project's true business purpose. So if you look at this figure, it is the example of a waterfall approach, okay, which is usually IT projects will follow a sequence of activities like this. Okay, so it begins by gathering project requirements, then design the software, then write the code to implement that design. Okay, um, test it, and finally roll it out. Okay, so the shaded part is the territory of IT specialist. Okay, uh, actually many corporate IT projects falter at these 2 points. Okay, they either don't get the requirements right or fail to gain traction with their intended business users. Okay, two major problems of a waterfall approach is the first one, the waterfall approach, you know, it erroneously assumes that a project team can identify business users' latent needs at the outset. Okay, for example, uh, here, okay, before the shaded steps begin, the project team is likely to give the users what they ask, what they ask for, but not necessarily what they need. Okay, and this leads to flawed requirement. Okay, and fail to roll out successfully. Okay, the second one, a lot can change during the window of isolation where the programmers and users have little interaction. Okay, for example, if a new requirement is discovered during Windows of isolation, then the waterfall approach requires redoing. Okay, which is may cause a huge cost. Okay, so with these two problems, these two problems described, we know that the waterfall approach lacks the flexibility to hit a moving target and the mechanisms to incorporate feedback. So this inflexibility can lead to the project's obsolescence uh, before completion. Okay, I hope you I hope you get what I'm trying to explain about the antidote, the first antidote. Okay, so now a solution to the waterfall problems is a lean discovery of business need. Okay, actually, lean approach to project management is also called agile methodologies. Okay, a lean approach to managing IT project will assume two things. Okay, the first one is business users cannot articulate an IT project's requirement, which means IT team must engage with business users to discover their latent needs. The second one is a success only in their eyes, which means the requirements will change over time, and the project is successful only if they find it useful. Okay, there are three principles for lean or agile methodology, which are active business participation, short iteration, and less code. Okay, lean idea number one, active business participation. Okay, the first lean principle is actively involving throughout the project. Okay, which is to prioritize what they actually need. Okay, for example, the latent needs, okay, should converge business users' objectives with IT technical knowledge of what is feasible. Okay, this figure uh, shows a convergence of business and technical knowledge prioritize project requirements. Okay, so IT and IT unit and business users, which is line function, are integrally participate throughout because they are in the same project team. So this active business participation will increase the prospect that a project will deliver intended business benefit. Okay, and for that reason, in lean approach, non-IT manager from line function often designates as the project owner. Okay, so the combination of business users and IT units, okay, should have these 5 characters. Okay, CRACK, CRACK, okay, collaborative, representative or business user, authorized to decide, committed to business value, and knowledgeable. So Lean idea number 2 is short iteration. Basically, this principle is about to do the project in a series of iterative sprints of 2 to 6 weeks each. Okay. Actually, each iteration hands users a crude but functioning system with small subset of functionality. Okay. Feedback on a prototype in users' hand is worth more than 1,000 presentation, right? Okay, when they see prototypes, okay, they can tell the project team whether what they see is what they want and what is missing. So integrally engage business users in a two-way conversation, right? Which means that a constructive conversation with a project team. Okay. A marathon many sprints. Uh, it is a marathon break into many sprints. Okay, this analogs about breaking a marathon into a series of 100-meter sprints. Okay, about this marathon analogs, which depicted in this figure, okay, which show us short iterations increase feedback opportunities for cheap and fast course correction. Okay, okay, how 6-month projects with a single iteration, which is typically for waterfall approach, provide zero feedback opportunities. And the same projects with monthly iterations, okay, provide 5 feedback opportunities. So basically, um, short iteration increase an IT project's likelihood of delivering business benefit in 2 ways. Okay, which is number one, clear misunderstanding earlier, cheaper to fix, meaning that by clearing up a misunderstanding earlier when they are cheaper to fix, they reduce the risk of building the wrong system. Okay, the second one is uncover latent needs, which is by focusing the team uh, on just what user need most, it Z wasteful over engineering and gold-plated functionality. Okay. Okay, lean number 3, less code, which is the aim of this lean is to reduce the amount of software code in system. So basically, every line of code explicitly justified with business objective. Okay, so the less code principle bakes quality and curbs cost in 2 ways. Okay, the first one is software with more code is buggier. Okay. Historical data shows that an average programmer make 10 to 15 errors in every 100 lines of code. Okay, so even the most rigorous testing cannot catch more than 50% of them. Okay, meaning that the more code, the more errors. Okay, and the cost of fixing an error is about 100 times greater after the software has been deployed. Okay, therefore, systems with less code are less buggy and cheaper to maintain. Okay, the second one is less code lowers upfront development costs, okay, which run between $15 to $40 per line of code. Okay, and implemented using 80-20 rules and a short iteration, okay, which is focusing on 20% of system which is focusing on 20% of system features that can meet 80% of its user needs, and shortening the iteration, as if lean idea number 2, to under 6 weeks. Okay, so other lean enabling ideas are constant automated testing, okay, and continuous integration, which reduce integration glitches at the end, right? Okay, lean payoff. Okay, this figure summarize how the three lean IT project management principles help build the right system around firms' real business need, which is faster, cheaper, and with a quality. Okay, okay. If with active business involvement, you can build the right system. Okay, with the short iteration principle, you can build the right system and cheap and fast cost correction. Okay, with the less cost, with the less code, uh, you can leads to cheap and fast cost correction and big quality system. Okay. Okay, lean or waterfall. Okay, this figure is about no matter what methodology you use, larger projects are the most challenged in delivering their promises, which is fewer than 20% succeed. Okay, now we have to choose either lean or waterfall approach. Okay, number one, the success triples if made smaller. Okay, the success rate triples if they are broken into smaller projects. Okay, where the benefits of lean approaches also become pronounced. Okay. Okay, the waterfall approach is appropriate for projects with clear definable stable requirement and proven technology, okay, or in projects of large scale. Okay, in contrast, the lean approach is appropriate for custom built business apps and for software embedded in products. Okay. Okay, now we go to antidote number two, curb scope. Okay, basically the biggest threat to IT projects almost always is trying to do too much. Okay, which is often too fast and with too few resources. Okay, so the only way to prevent such complexity from overwhelming a project is to focus on one or two really important business ends that you hope a project to achieve. So you can tame a project scope by using 80-20 rules. Uh, the heuristic that 20% satisfaction of a project features can meet 80% of its business needs. Okay, so non-IT manager can help identify the 20% by classifying each major project requirement using the Moscow classification, okay, which is a must have, which are must have, should have, could have, but not critical, and won't have this time, but maybe later. So the must have requirements are the 20% requirements that a project must prioritize. Okay, such prioritization focuses the project team and ensures the line functions do not make impossible demands. Okay, so the last antidote is accountability without micromanagement. Okay, there are two aspects to judge project's success, which is the first one is was it executed well in terms of its schedule, budget, and quality? And the second one is did it deliver the desired business result, which measured by an operational business metric. Okay, so many IT projects fall into the second aspect where non-IT managers are not involved at a few critical junctures. Okay, so the third contributions, which is antidote from non-IT managers, is holding the project team accountable for delivering desirable business benefits. Okay, such benefits are a project's measurable organizational value (MOV), which must come from a line function. Okay, and begin with the intended impact and emphasize desirable outcomes, not features, but be balanced what's ideal and realistic. Okay, uh, collaborative involving all project stakeholders, and ensures IT folks are evaluated first as business people. All right. So any MOV statement deserves a cold hard look at how it will further your firm's operational strategy. Okay, this value has to be measurable to your organization. Okay, so MOV statement for any IT project must have these four elements. Okay, first one is intended impact, meaning that what operational, strategic, or financial impact will the project have. Okay, the second one, promise, will it help do something better, faster, or cheaper? Okay, change metric. What is the unit for measuring impact? Okay, dollar, percentage, or time. Okay, and time to impact after project. Okay, what is the time to impact after project completion? Measure either it's measured in years or in a month. Okay, so details of how you will achieve the MOV do not belong in the MOV statement. All right. If a project's entire MOV cannot be expressed in one line, its scope is too scattered. So try making your project MOV pass the tweetability test by fitting it into a short sentence, right? So this project Pixie Darts actually just to show you the bad examples of MOV statement. Okay. Okay, next topics is rollout strategies. It is about how you roll out a completed project to its business users affects its reception. Okay, usually IT units pay insufficient attention to roll out uh, in a rush to get a completed system up and running. Okay, so a poorly uh, chosen rollout strategy can hurt users' receptivity, potentially jeopardizing the project's business payoff. Okay. Okay. In this figure, illustrate the three strategies for rolling out a finished project. Okay. The first one is direct cut over is the fastest. Okay. It's about the old system that is being replaced in simply turn off, and the new one simultaneously turn on the rollout date. Okay, meaning that the migration of any data from the old system must be completed before the rollout date. Okay, so the risk is that any bugs or glitches in the system can have a widespread impact. And technology glitches often lurk even if completed projects are pilot tested with a small group of actual users. So direct cut over is appropriate if the old system is unusable and if the new system is not mission critical to your firm's core operation. Okay. The second one is parallel rollout. Okay, where the old and new system are simultaneously available to users for an extended period, and the old one is subsequently turned off on the rollout date. Okay, this approach provides a safety net for technology glitches. Okay, however, it prolongs the rollout period and requires reconciling data from the overlapping period between the old system to the new system. Okay. The third one is a phased rollout approach. Takes the parallel rollout one step further. Gradually introducing the new system is less overwhelming, bite-sized chunks of functionality. Okay. Although a phased rollout is preferable, but business pressure to get a new system quickly up and running can make it less feasible. Okay, this is about rollout strategy. So we summarize this chapter 7 with 5 key takeaways. Okay, the first one is IT project have dismal success rate, meaning that most IT projects either fail to get completed within a firm's constraints or fail to deliver intended business benefits. Okay, for example, trifecta is amplifying business penalties, and technical successes can still be dismal business failures. Okay, the second one, 3 reasons why IT project disappoint firms. Okay, ambiguous business goals, unneeded complexity, and silent non-IT managers, meaning that having an imprecise purpose, having more complexity than necessary, and failing to make an explicit cost schedule scope trade off jeopardize them. Okay, their antidotes are using lean methods to discover a project's latent business needs, curbing scope, and creating clear accountability for business result without micromanaging the project team. Okay, the fourth one is why lean often beats waterfall. Okay, the waterfall approach cannot accommodate evolving business needs and new requirements. Its lean rivals support flexibility, assuming that business users cannot articulate project requirements early on. However, it works better for smaller projects. So, 3 principles undergird lean project management. Okay, meaning that lean approaches to IT project management support active business participation, short and frequent iterations, and minimal codes. Okay, the last one is Moscow rules. It is about 80-20 rules, which is to focus an IT project and identify 20% of its feature that will meet 80% of its business needs. Okay, so usually non-IT managers can use the most core rules to classify project requirements into must-have, okay, which is the 20%, should have, could have, and won't have. Okay, I think that's all for chapter 7. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Thank you.